this worked better than the last one. So 56, we've got an isosceles triangle with its two equal sides of 4 inches, and it has the angle between them changing at 10 degrees per minute. How fast is the third side of the triangle changing in inches per minute when the angle between the two given sides is 60? So one thing we know right now, if the angle between is 60 and these are two equal sides, we know that this is 4 at the moment. We also know that these two angles are 60 because right now it's an equilateral triangle. That's changing, but at the moment that's true. So what I started out thinking about was, I know this angle is 60 and I know these two sides, and I wish I knew something about the side across, so I used law of cosines. So I'm going to do A being this bottom side, and then B and C are these two unchanging sides. So I start with A squared equals B squared plus C squared minus 2 BC, and then cosine of angle A, which will be that top angle that's also changing. Putting in the things I know for sure, B is definitely 4 and not changing. C is definitely 4 and not changing. These two are both also 4. So I finally ended up with A squared equals 4 squared plus 4 squared is 16 plus 16 or 32, minus here 2 times 4 is 32, cosine of A. So now I'm ready. I've got a relationship between the things that are changing, and I'm ready to find the derivative. So I found the derivative, which was 2a dA dt equals, the derivative of 32 is 0. The derivative of this thing will be positive 32 cosine A times dA dt. Okay, and that's all okay. Now I'm ready to put in some information that I know. I know that in calculus, when I'm looking at things that relate to change, radians are almost always the way to go. The only time we actually keep degrees is if the problem has units such that degrees are going to cancel. And this one makes me nervous, so I'm going to go ahead and make this 60 degrees into pi over 3. And this 10 degrees here in the problem, I'm going to think about that 10 degrees times pi over 180. To convert that, I get 1/18 pi, or pi over 18 in radians. Whenever I'm dealing with derivatives, the units, if I'm not sure about those and how they're going to cancel, I would use radians. Okay, so I'm ready to plug some stuff in here. 2, I know A right now is 4. It's changing, but that's what it is. dA dt is what I'm looking for. Equals, over here I've got 32. Cosine of the angle right now, so cosine of 60 is what I'm looking for. Cosine of 60 degrees, or cosine of pi over 3. Here's my 60 degrees. Cosine with 30 would be 1/2. So this will be 1/2 in there. Nope, I forgot. I didn't do my derivative correctly. This should be sine. Try again. I don't think I'm going to start this video over, but so, there we go. So this will be square root 3 over 2 because of my reference triangle. Then dA dt is the thing I did know. It was 10 degrees per minute. So I'm going to put in my pi over 18 there. I'm almost ready to solve. I know that 2 times 4 is 8, so I'm going to divide by 8. Here, divide by 8. And with a little calculator button pressing, I end up with the answer 0.605. And that is A on the multiple choice answer on number 56, and I think that one is correct. So thank you, and I'll try the next one in a while.